What's up, friends? Today we are going to have do the LEETCODE problem called threesome. But before we do that, we of course have to do our wildlife wild fact. And today, ladies and gentlemen, I want to introduce you to the pistol shrimp. The pistol shrimp is one of the deadliest animals in the world. Despite the fact that it's smaller than your finger, one of the claws of the pistol shrimp, when used, shoots an air bubble at up to 62 miles per hour, which makes it the deadliest shrimp on Earth. I don't know about you, but I don't want to be on that menu. So today we are doing LEETCODE number 15 called threesome. Honestly, I can't say that with a straight face. Number 15 called threesome. It is a medium level LEETCODE problem, and it is one of the top 200 interview questions on LEETCODE. So the first thing we need to do is read threesome's description. Threesome says, given an integer array nums, return all of the triplets, nums at I, nums at j, nums at k, such that I does not equal j, I does not equal k, and j does not equal k, and nums at I plus nums at j plus nums at k equals 0. That is saying we want to take as many triplets of numbers as we can that, when added together, equals 0. And we have to make sure that we are not using the same elements in the array. We can use the same numbers in the array, but we cannot use the same elements in that array. So let's look at an example, and hopefully you'll understand it a little bit better. If we're given an array, nums, that contains -1, 0, 1, 2, -1, and 4, we want to return two different triplets. Those triplets are -1, -1, and 2, as well as -1, 0, and 1. Both of those triplets are groups of three numbers that are different elements in this array, but add up to 0. Take note, we use the number -1 twice, but we're allowed to because -1 occurs twice in this array. If it only occurred once in the array, this would not be a valid triplet. If we look at the next two examples, these are great examples of edge cases that we can account for. So when we're given an empty array, obviously we don't have enough elements to create a triplet, so we just return an empty array because we have no triplets. Same for example 3, even if we're given an array with only one element inside of it, we still don't have enough elements to make a triplet, so we return the empty array again. Okay, let's get this threesome rolling. So if I want to take a hint from the edge cases that they gave us, right off the bat, I know that if the length of the nums array is less than 3, I don't have enough elements to make triplets out of, so I can automatically return an empty array. The next thing I want to do is create my result array. That's going to be the array that we return at the very end. And from there, the next thing I want to do is sort my input array. And I want to sort my input array because it actually is going to help us with the strategy that we're going to use in order to find these triplets. And I'm going to sort it by A minus B. And if you don't know what this is it sorts it by taking in a pair of numbers as it iterates over the array, and for every pair, it subtracts one from the other. And then depending on whether that result is negative or positive, it actually is able to sort the given array. After we have the sorted array, if we take the first example here, what we are actually going to be given is an array that looks like this. We'll have a -4, a -1, and a -1, and a 0, and a 1, and a 2. All right? So that's what this array will look like afterwards. And once we have our sorted array, we can start looping through our nums array that is now sorted. Inside this loop, there is two things that I need to do before I move forward. The first thing is I need to create two more variables. Now, if you haven't guessed it yet, we are going to use a 3-pointer method for this solution. So my second pointer, the first being I, is going to be a j. And j is always going to start at the next element from I. So that is at index I plus 1. And j is now going to start at the back end of the array. So k. So k is going to equal nums.length minus 1. And what we're going to do is, while we have a value stored in index I, we're going to take index j and index k and move them towards each other while we look for these triplets. Before we do that, though, we need to account for this duplicate problem that we have. We're not allowed to return duplicate triplets. So for instance, with this initial output on example 1, we have -1, -1, and 2. Well, since we have two -1s, there's the possibility to put that triplet in twice. But we don't want that. So we need to find a way to say, if we've seen this value already as an index at I, we want to skip this iteration altogether. And in order to skip this iteration altogether, it's just going to require a simple if statement. We want to make sure that I is not at index 0, and we want to make sure that nums at I is equal to nums at I minus 1. If either of these are true, so if I is not in index 0, and if the element that we are on is equal to the element before it, then we know that I has come across this value before and we can skip. And the way we're going to skip is by saying continue. And if we continue, this for loop will automatically increment I for us, but will also go on to the next iteration of the for loop, and we can keep going. So now that we've made that possible, we want to start making j and k move closer and closer to each other while we look for these triplets. Keyword, while. You guessed it, I'm going to make a while loop. So, while j is less than k, let's do something. What is that something? Well, at every time we have a new value of j or k, I want to create a sum. And that sum is going to be the sum of all of the places of our indices, our current indices I, j, and k. So nums at I plus nums at j plus nums at k. And now, since I have this lovely variable sum, I can do some checks. First, I want to say if our sum is equal to 0, which is really our target value, we want to push into our result array another array that is our triplet of nums at I, nums at j, and nums at k. So that will be our triplet. The next thing that we want to do is increment j, because we don't want to stay at these current indices, we want to keep looking. And the way to do that is going to be by incrementing j, one index further towards the end of the array. And we actually have to do one more thing here. Similar to checking to make sure that we don't use the same I value twice, we also have to make sure that we don't use the same J value twice. So I'm going to create actually another while loop here, and I'm going to say while J is less than K, and similar to before, nums at J is equal to nums at J minus 1. So this is going to continually move J towards K again, towards the end of the array, as long as nums at J is equal to the element before it. And that's going to ensure that we don't use the same element twice as our J value. Now, I have to use a while loop here because I don't have access to a continue in the way that I want to. I could use continue before because my for loop would automatically increment I, but this time I don't have any way of automatically incrementing J, so I have to do this while loop instead, which will increment J every single time. And once it finally breaks out of that while loop, we will move on past these if statements and back into the while loop for another iteration. But before we do that, we have to make our else statements. And our first else if is going to be if sum is less than 0. So if the sum is less than 0, we know that the sum is too small. And if the sum is too small, since we're working with a sorted array, the way to make the sum larger is by incrementing J again. So I will say J++. And that's all we have to do there. The only other possibility is if sum is greater than 0. We've already accounted for sum being equal to 0, and we just accounted for sum being less than 0. So if the sum is greater than 0, the way we remedy that is by decrementing K. If we decrement K, the sum will become smaller. Again, this is possible because we are using a sorted array. And that is all we need to do. Except at the very end, of course, we need to return our result array. So if all goes well, we will continue moving I through this array. And as we move I, each time J and K, depending on the value of our sum of the three values, we are going to move J and K closer to each other until they overlap. And once they overlap, we break out of that while loop again and move on to the next iteration of our for loop, and we do it again and again. Now, one thing that I forgot to do is actually we can say for our for loop, we go while I is less than nums.length minus 2 because we have 3 pointers. And those 3 pointers, once we get to the last 3 elements of the array, are going to end up as the last 3 elements of the array. So we have no reason to move I any further. So we go ahead and we submit the code, and thank God we got the right answer. I will submit the code, and there we go. It's not the fastest solution, but it is a good solution, and it's really good practice for doing pointer methods. Most popular is obviously the 2-pointer method. Here we were able to utilize a 3-pointer method, which is really, really great. Before you go, I would really like to do one walkthrough of this code with you. We are going to take this first example, and luckily I have this first example already here. We come in to this function, and right off the bat, the first thing we do after our edge case and we create our result array is to sort our nums array. And here it is, all sorted for us already. We know already that we're going to create three variables. So the first thing that we do is create this variable I when we go into our for loop for the first time. So I'm going to put I, j, and k up here, and that's at index 0. And we go into our for loop, and j is going to be equal to I plus 1, and k is equal to the element at the end of the array. So we go all the way to the end and put k. Okay, the first thing we check is if I is not equal to 0. Well, right now I actually is equal to 0, so we can skip this if statement and we go right into our while loop. And we say, while j is less than k, sum is going to be equal to all of the elements at I plus j plus k. So, -4 plus -1 plus 2 is -3. Is -3 equal to 0? No. Is -3 less than 0? Yes, it is. So we increment j to -1 again. We increment j to 2, which is -1 in the array. And we go to the next iteration of this while loop because j is still less than k. Well, the value of j, of nums at j, hasn't changed. So we know that the sum is still less than 0, so we're going to increment j one more time. It's still less than k, and our new sum is -4 plus 0, which is -4, plus 2, which is -2. Well, -2 is still less than 0, so we're going to increment j again, and our new sum is now -4 plus 1, which is -3, plus 2, which is -1. Well, still not 0, so we're going to increment j one more time, but this time j is no longer less than k, so instead we go on to the next iteration of our for loop. I gets incremented from 0 to 1, j goes back to being I plus 1, and we can finally hit our if statement. If I is not 0, well, now I is 1, and nums at I is equal to nums at I minus 1. Well, is -1 equal to -4? No. So we don't hit the full if statement here, and we go again into our while loop. Now, our current sum is -1 plus -1, which is -2, plus 2, which is 0. Hey, look at that. So, sum is equal to 0. We hit this if statement. So we push this array into our res array, which is here. I'll put it here. So this becomes -1, -1, and 2. I will remove these. Okay. So we have our res. We're going to increment j. Now, while j is less than k, and nums at j is equal to nums at j minus 1. Well, j is less than k, but nums at j, which is 0 now, is not equal to nums at j minus 1, -1. So we actually don't hit that while loop, and we go on to the next iteration of our outer while loop. And our new sum becomes 0 plus -1, which is -1, plus 2, which is 1. Well, 1 is actually greater than 0, so we're going to decrement k. And now, the value of nums at k is 1. So, in the next iteration of our while loop, sum becomes -1 plus 0 plus 1, which again actually is 0. So we push the new triplet into our result array, and after we do that, we increment j, and we look at our while loop and we say while j is less than k. Whoop, actually, j is equal to k in this moment, so we don't hit that. We break out of our while loop, and we also end up breaking out of, we break out of our while loop, and we go on to the next iteration of our for loop. So we increment I, and we put j at I plus 1, and k goes back to the end of the array. Now, this is important. If I is not equal to 0, and nums at I is equal to nums at I minus 1, it actually is, because nums at I is -1, but just before this, nums at I was also -1. So we don't want a repeat of our -1, 0, 1 triplet, so we're going to continue. And when we continue, we increment I again at the end of this would-be iteration of this for loop. So we increment I to 0, to 0, 1, 2, 3. And we continue on like we would normally. So j is equal to I plus 1, so 4, and k is equal to nums.length minus 1. We're now at the last 3 elements of the array. We know that we don't hit this if statement, and while j is less than k, sum is going to be equal to nums at all 3 of those added together. So 0 plus 1 plus 2, well, it's definitely not 0, it's actually 3. And 3 is greater than 0, so we are going to decrement k. And when we decrement k, j is no longer less than k, they're equal again. And so we break out of that while loop, and since we have broken out of that while loop, and I is now no longer less than nums.length minus 2, we are actually ready to return our result array. And that goes right here. So that, ladies and gentlemen, was the walkthrough for LeetCode number 15, 3-sum. And I hope you enjoyed it. Please don't forget to like and subscribe and comment below. If you like the wildlife wild fact, there are plenty more where that came from. Otherwise, I'll see you in the next one. Bye-bye.